As scientists have done experiments and learned more and more about atoms, they've changed the way they think about atoms. So in this video, we're going to look at a timeline of the different ways that scientists have pictured or imagined atoms over the years. Now, the first people to really talk about the idea of atoms were the ancient Greek philosopher Democritus and his teacher Leucippus. They lived about 2,500 years ago. And Democritus, he said something like this. He said, imagine you have an object, like say a slice of bread, and you cut that in half. And then you take half of that and you cut it in half. And then you take half of that and you get the idea. Eventually, he said, you're going to come to something that you can't cut in half anymore. And he called these objects, he called them atomos, which means uncuttable, and it's where we get the word atom from. Democritus imagined that all matter, all stuff, was made of these tiny, uncuttable particles. And he imagined that the atoms came in different sizes and different shapes. He imagined, for example, that iron atoms had hooks, which is how they could hold together so strongly. And he thought that salt atoms had spikes on them because he felt that salt tasted sharp. So, Democritus was right. But people didn't really take to his ideas. Part of the reason was because around the same time, the well-known philosopher Aristotle proposed his own idea of what matter was made of. He said that different things were made of different amounts of the elements earth, water, air, fire, and ether. This is kind of like Captain Planet if you're old enough to get that reference. And more people believed Aristotle, maybe just because he was so popular already. So Democritus and Leucippus, they were right all along. But here's the thing. They weren't scientists. They couldn't do experiments in the laboratory to prove that they were right. And because of this, some people think that their idea, it was just kind of a lucky guess. They couldn't actually prove what they thought. So, how can you tell whether it's right or wrong? Ideas about atoms remained that way for about 2,000 years. Until in 1808, the British chemist John Dalton came up with the first scientific experiments that showed that matter was made of tiny little particles. This is kind of how John Dalton pictured atoms. He imagined them sort of as tiny little balls that arranged in different combinations to make different things. And he imagined that these atoms were indivisible. You couldn't cut them into smaller pieces. Now, at first, nobody believed Dalton. But over the course of the 1800s, more and more scientists did begin to believe what he had to say. But then in the 1900s, the early 1900s, people's idea about atoms started to change. One of the key things that caused this change was that in the late 1800s, J.J. Thomson discovered that atoms have electrons. And he discovered that electrons are much, much smaller than atoms. So while Dalton thought that atoms were tiny and indivisible, J.J. Thomson said, no, they're not indivisible because they're made up of electrons, which are much smaller. So J.J. Thomson pictured the atom as sort of like a blueberry muffin. He called this the plum pudding model. J.J. Thomson imagined that if you took an atom and split it open, you'd see tiny electrons stuck throughout the inside of it, just the way blueberries are stuck in the dough of a blueberry muffin. And Thomson thought that what's the dough in a blueberry muffin? That it was like a positively charged substance. So you had negative electrons stuck in like a positively charged dough. And together, the positive and negative charge balanced, the two things balanced each other out so that the atom was electrically neutral. But the big change from Dalton's model to Thomson's model was showing that atoms weren't actually indivisible, that they were made of even smaller things. Now, not too much longer, in the gold foil experiment, Ernest Rutherford discovered that atoms had a nucleus, that all the positive charge in an atom was concentrated right in its center, and that besides that and the electrons, atoms were pretty much empty space. So J.J. Thomson thought the positive charge was all distributed throughout, like dough in a muffin, but Rutherford showed that all this positive stuff was concentrated right here in the center. And this is what we call the nuclear model of the atom because it has a nucleus. Sometimes people call this the Rutherford model. Now, so far we've been talking a lot about the positive charge and the nucleus of an atom. But we haven't talked too much about what's actually going on with these electrons in the atom. And in 1913, the physicist Niels Bohr came up with his model of the atom. He reasoned that there was a nucleus in the middle, just like Rutherford had, but that electrons, instead of just sort of being randomly distributed throughout the atom, Bohr said that the electrons were sort of like planets around a sun, that they were spinning around the nucleus in circular orbits. So here are a picture of some of the electrons, and here are the orbits. Imagine that they're spinning around the nucleus in these circles. All right, now, people thought Bohr's idea for the electrons made a lot of sense at first, but then in the 1920s, additional experiments showed that it wasn't exactly the way electrons really move. And a variety of physicists, particularly the physicist Erwin Schrödinger, showed that electrons weren't really spinning in orbits, but it's more like they were hyperactive flies, and they were buzzing around the atom, sketching out different shapes. It's kind of if you did like time-lapse photography on a hyperactive fly, and you saw that over a long period of time it sketched out a particular design. And whereas Bohr called these circular paths, he called them orbits, Schrödinger called the hyperactive sketch-out shapes, he called them orbitals. Here's a circular orbital too. But electrons didn't only make circles. This is actually a sphere because it's a circle in 3 dimensions. Here is another shape, another type of orbital that electrons could also make. Looks like this, sort of 2 teardrops next to each other. So in the quantum mechanical model, electrons don't orbit the nucleus. They buzz around the atom, sketching out different shapes. Now let's focus on the nucleus here. Over the same amount of time, and a little bit later, scientists were discovering the 2 subatomic particles that make up the nucleus. So we can refine this picture a little bit more. In 1919, Ernest Rutherford discovered protons, there they are, and then in 1932, James Chadwick discovered neutrons. So the really correct view of the quantum mechanical model shows the orbitals being sketched out by the electrons, but then also shows the subatomic particles, protons and neutrons here in the nucleus. Now, this is pretty much how we think about atoms today. But as scientists learn more and more about atoms, as they do more experiments, they're going to find that this model isn't exactly a perfect representation of what atoms are really like, and they're quite likely to change this and refine it even more. Now, as I said, this quantum mechanical model is like the really accurate way to describe atoms. But the thing is with these orbitals, it can really be kind of a pain sometimes to describe simple things that atoms are doing using electron orbitals. And so a lot of times in these videos, when I talk about atoms, I'm actually going to be sort of using a cross between the very correct quantum mechanical model and the sort of outdated Bohr model. Just because for our purposes, a lot of the simple things we're going to be talking about, the Bohr model, it works just fine. So already you've probably seen me draw atoms like this, where you see the electron orbits at different angles. And sometimes, particularly when we're talking about bonding, we're going to be drawing atoms like this, with the protons and neutrons here in the nucleus, and then electrons in different rings, different orbits on the outside of the atom. We're going to find that thinking about the atom like this is very useful for simple tasks, talking about bonding and stuff. But keep in mind that when we're discussing atoms, they actually aren't exactly like this, and they're much more like the quantum mechanical model. So keep in mind that I'm lying to you a little bit, but I'm lying to you in order to make it easier to convey some fundamental topics.